So here we are, transforming graphs. We'll be looking at reflecting graphs in the y-axis and the x-axis. We'll be looking at translating graphs along to the right or along to the left, horizontal with the x-axis. We'll be looking at, let's have the two reflections. Yeah, and we'll be looking at translating graphs directly vertically in the direction of y, or translating graphs directly downwards in the direction of y. So there's 4 transformations we need to look at, and there's a couple of examples of each. Here's the first one, so please pay attention. I want to go large on this, larger than that large. So that's just the title. Be respectful of titles. Here's the first transformation. You'll recognise this little black one here. That looks a little bit like y equals x squared. I just called it a generic y is some sort of function of x. Don't need to define it, I just drew it. What you can do is raise this graph of y equals x squared by a certain amount. So for example, if you're going to transform y equals f of x into y equals f of x plus a, it's just a number. This could go from, say, x squared to x squared plus 3. All right, so let's give it a live go here. E.g., we could be talking about y equals x squared. And here we could be talking about, for example, y equals x squared plus 3, which will make the intercept right there, Lucy, 0, 3. All right, so I've just transformed that shape using a vector. What did the vector do to this little black graph here? It translated it a units in the vertical direction. What does that look like as a vector? I went 0 along and a up. I didn't go right, I didn't go left, I went 0 along. If you remember your vectors from year 9, which was the last time we did vectors, okay, 0 along and then a straight up, bam, that's it. So how do I describe the move from this black line to this blue line? Answer, this transformation is a translation of the function using the vector 0a. In the same way, I can translate it downwards by a units. So this could be, for example, y equals x squared. Let's drop it down 4 units. So for example, therefore, that intercept would be 0, -4, yeah? So here I go. So I'm going to translate this one 0 minus a. I'm dropping it straight down 4 units. Is that okay? So this is the upward movement of a graph or function, a downward movement of a graph or function. Very easy to spot. It's the number that's stuck on the end. You must action that number and it goes either up or down depending on the sign. Transformation number 1, a translation using a vector. It's just up or down. Here's number 2. This is very counterintuitive. Here's my original y equals f of x, and I've said, well, let's just call it x squared because it looks like it. This time, if you take every x value in a table and take away something from it and then apply the function, that means you take your x value, take away, say, 4 as an example, and then you square that answer. Something really strange happens to the graph. It doesn't go 4 to the left from the origin. It actually goes 4 to the right from the origin, which is very counterintuitive. And so I actually worked out what x minus 4 squared would look like as a solution. Well, here's the line y equals 0, the x-axis. So I've called it x minus 4 squared equals 0. I then wrote 2 brackets side by side. And as you can see, there's only one solution. This is a perfect square. It's x minus 4, one bracketed term, squared. Just a perfect square. And the solution is x minus 4 equals nothing, so x equals 4. Well, of course it is. We just solved it because we know how to solve simple quadratic equations. So if the root is 4, it's not minus 4 over here. So even though this would appear, you should take the pink graph and take it to the left, it actually translates to the right. Counterintuitive, but hey, I know you get this maths. You can see why x is 4 and not minus 4. So this transformation of y equals f of x minus a translates the function using a0. In other words, you take 4 to be the a, look, directly linked, and don't go minus a, no, you just go a itself, bang, 4 across, 0 up. So we're translating the original function using the vector. I should have the word vector there, so you could learn the proper words, using vector a0. We're going across, not left, okay? That's the second transformation. Here's another example. Supposing, once again, this lovely black function, y equals f of x, for example, y equals x squared. Now, if I then take my x values in a table, add something onto them, and then apply the function, i.e. then square it, and then square it, I get something very counterintuitive. It doesn't go to the right 4 units. Obviously don't, because we've just done this one where it goes to the right 4 units. This goes left from the origin 4 units. So let's see if it actually works. Again, I multiplied this all out and tried to find the single perfect square root. So y equals x plus 4 all squared, which equals 0, because that's the line y equals 0, you may recall. Again, perfect square, x plus 4 multiplied by x plus 4. There is only one solution, x plus 4 equals 0. Then you take the 4 over, and of course you subtract it. So y equals x equals negative 4. Yeah, look, there's the coordinate, negative 4, 0. You go left 4 units, not right 4 units. Like I said, counterintuitive. Okay, so that's that. So the function y equals f of x is translated using the vector minus a 0. So you take the a there, 4, and say, I'm not going to go to the right, I'm going left. So you turn left and go minus a, which is minus 4 along, 0, because I'm not going to move the graph up or down. We've done the up and down bit. Is that okay? So that's function translation rather number 2. So what have we got so far? Let's just revise. We go up or down the y-axis. We go left or right across along the x-axis. 2 rules, 2 more to go, and the last 2 are very, very easy. This is the only tricky one. This is easy. Look at this. This is obvious. So here I go again. Here is the graph of y equals x squared, my generic function. If you put a minus in front of the function, you end up with y equals minus x squared. In other words, and if you go and plot it, you end up with something that looks like that, otherwise known as a reflection in the x-axis. Absolutely for sure. You've plotted these all in year 9, negative x squared graphs. You've done the x squared graphs that do that, and the minus x squared graphs that do that. And one's the pure reflection of the other in the x-axis. We're not moving it left or right, up or down. It's a pure reflection. So it's not surprising that y equals x squared becomes y equals minus x squared. All right, easy that one. So that's called a reflection in the x-axis. Number 4. This is called a reflection in the y-axis. Now you will now all recognize this style of graph. This style of graph is called an x cubed style of graph. In fact, I called it y equals x cubed just to keep it simple. And so I've defined my function as y equals x cubed. This time, if you're to plot it the long way, you make the x value negative. So if x was 2 originally, then you call it minus 2. Then you apply the function of cubing. All right? And you will end up with minus x cubed, because minus x times minus x is plus x, multiplied by minus x again. Sorry, minus x times minus x is plus x squared, then multiplied by minus x again. So I go plus and minus is minus x cubed. Not surprising. And again, when we did the sheets from before on cubic graphs, you plotted a few negative ones. I told you this was all going somewhere, and it's coming to this. This is it. So what's happening? So there's my x cubed function. Here's my transformed function, which is a reflection in the y-axis. So what I'm trying to show is this little blue branch here gets reflected in the y-axis and goes over there, and this little blue branch here gets reflected in the y-axis and goes flying over there. to produce this lovely curve as shown. That's easy to understand, isn't it? So that's that one, and I thought I'd try another one just for funsies. It's the same rule. I'm doing a reflection in the y-axis. So this time I wanted to use an exponential graph. Again, you've plotted exponential graphs. You know how they sort of take off, or if they're negative powers, they take off around the other way. So I've called this one y equals 2 to the power of x, my original function. If I reflect it in the y-axis, my new function, it's y equals function minus x. Yeah, so what do you mean? Well, instead of calling it y equals 2 to the power of x, I'm now saying y equals 2 to the power of minus x. And you know y equals 2 to the power of minus x is like saying y equals half to the power of x. Remember those tricky questions at towards the back end of your exponential functions where you had to identify 4 graphs with 4 equations? Well, I told you this is all going somewhere, and this is it. So there we are. Let me just reiterate again. We have moving up and down the y-axis, translations, moving left and right across the x-axis, more translations. We have a reflection in the x-axis, and we have a reflection in the y-axis with 2 examples. Now, I need to get rid of this. What I've done is taken screenshots of all of this so that when I send it to you and show my homework, you need to either look at them and draw them yourself, or if you have access to a printer and some colours as well, you can print off and stick it in your books. By books I mean lined paper that goes in your fat Year 10 folder, which must be getting quite fat by now. But do not ignore this, because if we're in class, I'll be waiting for you like this for you to draw all of it, and I'll be taking questions. All right, that is what would be happening right now. So therefore there isn't time for that in a half-hour slot. So what you're going to have to do is do what I've just said. If you can't print it off because you don't want to do it, you have to draw it. Simple as that. And by it I mean all of these are it. That one, that one, that one, that one, that one. Amen. So I'm now going to flick over. Oh, and that one as well. And what's after this? Not a great deal. I want to get out of this if I can. We don't need this just yet. That's going ahead to other lessons. The first of your sheets that's attached to this lesson is as follows. And I have actually demoed that as well. Yeah, there it is. The reason it looks ugly is because, number one, it's taken from the Red Book, and the Red Book has got questions in it that are no longer relevant to our specification. So all of these questions, number 5, number 7, number 10, sorry, that's number 4, all these where there's blanks, I Tipp-X'd it out ages ago. And I only left the questions that are relevant to our specification. That should be called question 2, but it isn't. Again, this is a graphic taken from the Red Book, and as are they. They look absolutely horrifying. You shouldn't be baffed by g of x and h of x. Doesn't matter. They're all different functions. This one you should fall in love with. Look, it's a beautiful sine wave there. That is a tricky one, but it doesn't matter. You don't have to identify it. You need to move it around. And there you go. And these are, if you like, 2 functions stuck together that don't have an equation at GCSE. I won't even tell you what that is. That's beyond where you're at, and where it's beyond where you're going to be. So these are screenshots taken from the Red Book, which I've put together on one sheet. It's a booklet, and you need to deal with that. So here's this part here. Let me just launch it. They give you this in the Red Book, and they just called it y equals function of x. Yeah, all right, good, obviously. Copy the diagram, drawing the axes marked from -4 to 4 in all directions, because you're not quite sure where the graph's going to end up after you've transformed it. Then they want you to draw the function of y equals f of x plus 2. Anyone got any ideas what's going to happen if I go function plus 2? Somebody unmute themselves and teach a bit. So who are the leaders? It says f of x then plus 2, not f bracket x plus 2. It's function plus 2. It will crawl up this y-axis. How many units? It's exactly what it's just 2 units. So once you've done that, do the other 1, 2, 3, 4, 5, 6. I gave you a bit of help there. That's not copied onto your sheet. I did it while I was preparing the lesson. And so that's going to be on YouTube anyway. It's a lot of drawing. I hope you've got graph paper. I really do, because line paper, even though you can have a line to be worth 1 unit, it's quite messy. I'm hoping you've got graph paper or an old yellow book from Key Stage 3. I'm just hoping. Otherwise, there's no space to do it on the sheet. This is not a worksheet we work on the sheet, apart from question 5 and 6, because there's loads of space to do it on there, really. Question 5 is just, do that to that. Before you go any further, you've just got to memorize and refer to the 4 different functions I showed. Up and down, left and right, reflecting x, reflecting y. Done. Like I said, I did demo the first one. That's going forward, and there it is. So if I put the grid on there, you can see it. Here's the grid displayed on the screen. Boom. Let's make it big. Even bigger than that. Even bigger than that. There you go. So I did what the book said. I went from 0 to 4 in all directions. This is the original function. So that must be the point 1, 1. That's the point minus 1, 1. And as Sam and some others told me, move it up 2 units. So my 1, 1 will become 1, 3. My minus 1, 2 will become minus 1, 4. Yeah, just add 2 onto each little bit. And of course my 0, 0 jumps up 2 units to 0, 2. So that's the original function on the worksheet. That is the transformed function, y equals f of x plus 2. And then you've got to say what it is. It's called a translation using vector 0, 2. 0 means don't go left or right. 2 means jump up 2 units, and draw it in really accurately with a ruler. Really, if you haven't got graph paper, you're going to have to start making simple grids like I've done on white paper. Originally, let's just get this out of the way. This is just white paper, but it's a white screen. That's what the Mimeo looks like. And so I carefully made some markings. It's obvious that's 1, and that's 1. It's obvious that's 2. And it's obvious what it is. So even if you did that on plain paper and it's reasonably accurate, I'd still give you all the marks. We're playing at grade 8 here, or thereabouts, certainly not below that. All right, so even if you don't have graph paper, okay, do it on ordinary paper, and just send the stuff to me and I'll mark it. Now, there are no answers. I've got, I can't look at the red book answers, even though I've got a red book here. I need to mark all of your work individually, every single question, which is why I'm asking people to don't delay sending me your work, because even though I'm saying the deadline for this is Saturday, don't wait for Sunday night, Monday, because I'll be preparing a week's worth of lessons going forward. I cannot be working 24/7 because I simply cannot. Right, so that's pretty much everything. That's a live example taken from our first sheet. Let's just reiterate again how many times. Here we go. You've got to watch the video, or you take these notes, you copy it all out in your own pretty handiwork with colours to highlight things, or you print it and stick it. I don't mind. So plus something, move it up. Minus something, move it down. This one, this time the something is within the bracket. You do something to the x first before you apply the function. In this case, subtract 4 and then square it. But of course, I'm not asking you to do a whole table of values. You're not plotting anything. You're moving, you're transforming a shape from one position to another, whether it be by translation up or down, translation left or right, or by the 2 different reflections we've got. So we've got the ups and downs, we've got the lefts and rights, we've got the reflecting x, we've got the reflecting y, and there's another example of reflecting in y, and there's the first example of what's in your book. So if I go back to that, this is your worksheet. All right, so I just demoed that one for you. Please note it says, Tino, describe fully how you got from there to there. Answer, translation using vector 0, 2. Any idea what this one's going to look like? Describe this transformation compared to the original f of x. What's that going to do? This, drop it down 1 unit. What's this one going to do? Is that Hamza? Thank you, Hamza. You're the leader. Okay, yeah, we're going to translate this graph to the right 3 units, but we've got to say for full grade 8, translate using vector 3 zeros. Cool. So 0, 0 becomes 3, 0. You see why you've got to draw your own little grids, because you're going to come off this little grid here. That's why I say go from -4 to 4, because it will look after everything. This is obvious. What's that one going to do? Just from memory of the function. Somebody speak. Yeah, move to the left. How far? Yeah, so this is going to go bounce, bounce. So that V is going to start about here somewhere. Is that all right? So that's going to go that way. Just making a mess of my worksheet. What's this one going to do? Do you know? Do you remember that from memory? What's that one going to do? Minus function of x. There is no such thing as a negative reflection. It's a reflection. So what do you think? It's definitely a reflection in which axis? Thank you, who said x. Yeah, you reflect this in the x-axis, so this would come flying down here. Look at that. It's really crude. Something like that. It's ugly, but it's completely correct. It would look something like that. And of course, on a proper grid, it would look amazing. Lots of little pictures. What do you think this one's going to do here? Speak up, please. It's exactly a reflection in the y-axis, yeah. It's exactly what's going to happen. And you won't like this one because that's going to go like this. Again, I'm drawing this freehand, and that's going to be over there. So that's going to go like that. There it is. So I've got the original black V and this little red V, which you think, oh, yeah, it's going to reflect on the y. It will look like that. So you can see why you only want one transformation per question. Don't get naughty and put lots of answers on one grid. They'll just cross over each other. It's awful. Now this one, this is designed to help you a little bit. The question is y minus f of x. In other words, minus f of x plus 1. Can someone talk through that one for me? Because there's 2 things you've got to do. And the order doesn't matter. It will end up in the correct place. All right? So somebody talk me through what you need to do to the original function, this little black one that I've mutilated. What's that going to do? 1 mark, then? That's it says plus 1. It's not in the bracket. Move it up 1. Yeah, good, good. Yeah, so this is not 2 answers. It's 2 parts to the one function. Don't say reflect it and then draw it reflected. You've got to imagine it reflected first and then lift it up 1 unit. All right? So the way you describe it is reflection in the x-axis followed by a translation of 0, 1. Okay? All right, they want me to go. I've gone a long time. They don't like it anymore. All right, so I'm going to have to stop. I can't take questions because we're out of time, I'm afraid. So I'm going to stop.